Good. I would say we start 3 minutes into the meeting. So, I just have a couple of organizational points, and then I guess we could start with Davide's presentation. Um, for the last meeting, as you see, we have now also put the recording on YouTube that I made. Unfortunately, my audio is missing, which I hopefully have fixed for this one, if my setup works. You can also find all the results from the things where I asked for your input. So, for example, this one was the goal of the working group. I thought this was quite interesting that most people are actually interested in these types of networking and knowledge exchange. Of course, we like if you look at the lower points, we don't have a whole lot of kind of code base where we could actually give support. Um, but I guess we could try to. I think this format with these short presentations that also works quite well with regard to this networking and then knowledge exchange, because if someone presents something, then all of us can learn, and then we can also in the discussion then later exchange ideas. But also the third point is of course important, that we try to at some point um, try to standardize these interfaces, and maybe we could see as a bit of an as a bit of a long-term goal, how to work towards that goal.
Christian,
Yes.
you are not sharing.
Oh, yeah. Thank you for the. That would be ideal if I would share. I just said that here in this protocol you can also now. This is the link for the video without my audio, and these are these, for example, the results for the goals that I just talked about. Um, and the other talks, I will see if I can also get the slides from Francisco to put here. The slides from Guillermo are here. Now it's even a link. And also like this one, I think it's quite interesting kind of from a technology point of view. A few points in here are also kind of implementations, for example, Plantsys and SMAC and so on, and you will find them later in this collection that we made. And then of course also in the last input I asked for this schedule, and this is actually the schedule that's now implemented. So the meeting is now regularly on the first Monday at 5 p.m. of our Central European time. Then the next point is I made a GitHub organization. So should we ever have it? Should we ever have a common code base? This would be the place for it. But there is, I made already one repository. This is this awesome list. That's basically a template for these lists, and the idea is that you kind of collect resources to a topic, and usually the criterion should be that you have personally checked out or had a look at this, whatever you are putting onto this list, such that the items on the list have a certain quality. I already filled this in terms of packages, so these are all the packages that um, were aware of. For this, I have the criterion that they should be ROS2 compatible, or should somehow work or be developed in ROS2. In terms of presentations, I looked through the last couple of ROSCons and put the ones that seemed relevant, but please always feel free to contribute more um, that may fit. We could also think about using the sections of the working group meetings that are the presentations and also put them here. Um, I added to the videos, I don't know if you've seen that, but to the videos I also added the chapter marks um, to the different talks. This would make it also possible to then just put a separate, just one of the talks there. If you click here, you can then see the different sections. And for example, then if you're interested in Jamie's talk, you could just use this. As I said, I'd like to keep link. So basically this link. Yeah. In terms of papers, it's a little bit empty. I still haven't got haven't found the time to put more here. The only thing is that one that basically was mentioned in Francisco's talk. And Sebastian already put some blog posts, so we have a separate section for blog posts because it's not quite the same thing as scientific publications. Podcasts, the same thing. These are just the ones that I had the pleasure listening to. And demos are more like videos, so there was the idea to have actual kind of looking at deliberation or whatever we're doing here in action. So, for example, there's the one from this Road Moses project where you can actually see what the behavior tree does and how the robot moves around. Yeah, so please feel free to contribute. You can always just a regular pull request kind of workflow. The next point is, going along with the YouTube videos, there's also a YouTube channel which has like exactly one video at the moment, and it's this one. In the next meeting, just as a heads up, I will be on a train to Bordeaux, so Ralph will step in and take this moderation. I will also try to attend, but I don't know. I think it will be the hour before Paris or something, and I don't know how good the network will be there. So Ralph will take over this moderation. And in case, and I'm actually traveling to the Ross Industrial Conference, which is co-located with this RossCon France. And I will also, of course, again, try to win people for this working group by mentioning it and matching all the other topics that I'm currently working on. And also, if you are there, would I be happy to have a chat. But of course, I guess we will. It's not that big. We will meet. I think this would be inevitable if you are there. Good. I have taken the freedom to change the order of these two presentations. I think previously they were in the other order, but I thought that Davide's presentation may be a little bit more on the basic, so to say, because the behavior tree library is of course something that is very present, and that's why I thought it would make sense to maybe have this one first, but it's to no particular preference. I don't have put any time boxes on these for now, so we just I guess we just see how it goes. I don't want to interrupt any good discussion, but if it of course goes out of hand, then I will try to have us moving on. So Davide, can you? I think you should be able to share your screen, and I I'm not able to hear you.
I think Davide had to leave the meeting and re-enter, so he doesn't seem to have presenter. Oh, there we go.
I changed that.
It's good now. Yeah.
But he's
Previously he had already, but no. Okay.
Yeah, but I still can't hear him. So. Okay. So maybe if there's an issue, then we just swap it again, and could we start with
Can you hear me? Can you hear me?
Yes.
Yeah.
Okay, but I'm not a presenter yet.
Should be.
I think he joined for a third time, so there's another Davide
okay.
in the attendees.
Once again,
Is there?
But no.
Is there?
So even
Okay,
two
now.
of you are presenters here.
Okay, I have it. Okay, perfect. Hopefully you can see my screen and you can hear me, right?
Yes.
Okay, good. So this presentation is not too long. It is, I'm not going to go through the usual, what is a behavior tree, what is the purpose, because from the last meeting we had, It looks like a lot of people already know about it and been very vocal in the last year, with presentations and documentation. So hopefully you already know what behavior tree are and how they fit into deliberation as a tool, maybe within a bigger system. And Sebastian will talk about other approaches. The purpose of this presentation for me is to kind of convince you that not all the implementation are made equal. So right now the library BehaviorTree.CPP is at version 4.2. And that 4 number is telling you that there's been many iterations and improvements based on the goal of creating something that would scale well. And as a software engineer, I think that many of you will have the same feeling. Very often you look at a piece of software and sometimes a library, sometimes it's too small. It does something well, it's easy to learn, but you can't go very far, or sometimes it feels like it's too big and it's trying to do too many things. So it's really hard to find the right spot where it's easy enough to learn and not too big. And maybe BehaviorTree.CPP is already reached the level where it shouldn't grow anymore. But I really would like to convince you why some features are there and why you can't really do the same in a weekend. So because at the end of the day, you can say, okay, you know what, I can just do this in 1 week. It's not such a big deal. It's very straightforward. And actually, there's much more. And so I'm going to tell you a little bit more about what is not immediately clear when you start using and learning the library and why certain design decision has been taken. So a little bit of history. So the first version of the library was taken, is basically a fork from the work done before 2018 from Michele Coladincise. And basically since 2018, I've been the only developer and maintainer, so the last 5 years. As you mentioned, that this started as a Rob Moses pilot project, so it was basically 9 months, not much. And since then, I decided to maintain this on my own, independently from any funding or project or company. So there are 4 main areas I'd like to discuss today that, in my opinion, makes this library a good implementation or maybe a better implementation compared to others, and why I'm doing that. So first of all, there is a strong influence from the domain of model-driven development and model-driven engineering. For those of you that are not familiar with it, you are lucky. You have a blessed life. But I was in this kind of project, and Rob Moses was one of them, and there's a lot to be learned. So I tried to take the interesting piece of information and lesson learned and apply them to this library. Then there is a strong focus on scalability and composability. So some of the design decisions that seems a little bit odd are really focused on achieving the ability to create very large trees. If you don't take those design decisions, it's almost impossible to do that. Then there is a feature that I think is really important. That is the observability. I may say, come for the beer tree and stay for the tooling. So observability is probably part of the tooling that I think is really important, because if you think about it, the beer tree is really at the top level, the deliberation level. That is the top, more visible layer for people that look at what a robot does as a process. So it provides, if you can create logs and record what's going on and create statistics, that is an information that has a direct impact on the ability of your robot to execute a certain task. So having a specific kind of logging and monitoring related to behavior trees makes for me particular sense. And then there is these new features that I presented in ROSCON in Japan about the new scripting language in version 4. I invite people to maybe look at that presentation where I go more in depth, but I will mention that to tell you also, this is, I think, something that is a little bit inspired by behavior trees in Unreal Engine. But at the same time, I think it's also novel. I haven't seen it in the literature, so it's my tiny contribution to the field, because I don't think there is any previous attempt to do it in the same way. So let's start with talking about model-driven development. I'm just copying and pasting here some definition from Wikipedia. For those of you, so and a lot of this description we start saying, this is a method to make the creation of software easier and faster. So everybody starts saying that. I have a problem with that statement. That is marketing. That's not a description. Also, because I haven't seen in my life enough success stories about model-driven development in robotics, despite at least 2 big European projects trying to make that happen. So I'm staying with the description that is a methodology to try to use modeling to create a standardized components and use design pattern with the goal of speeding up and standardize the development. And then but the basic idea, what I like to mention is that you look at the problem from a higher level of abstraction. So you try to take a step back and not look at the source code itself. If you think about it, for example, in object-oriented programming, classes represent as higher level of abstraction. But here we are taking either a more coarse-grained definition of what our software does. And this is not unlike what ROS nodes does, right? You have a ROS node that would hopefully does only one thing and does it well. Those would be component in a system. And when we talk about model, we say it is a representation of my software that is not the source code. It's something that I can understand, and I can understand what something does and what is the relationship with other elements of the system without going into the source code to understand that. Not even the documentation. So the good model should be self-documenting to some extent. And the relationship, and I think that I was really inspired by this different, methodology and way to look at software. And when we look at behavior trees, and to be fair, also to state machines, really what we see is a model. We don't want to think about the specific implementation. We want to understand what each of the blocks in my system, and as I said, this could be also true for state machines, represent how these elements work together. So, for example, in a behavior tree, these nodes represent chunks of business logic or condition and actions. We compose them together, and we want them to have sufficient information. This is key for what I'm going to describe later. Sufficient information to allow user to understand how they interact. So this is not about the computer. This is about the human reading these models. And then we want to be sure that this model also allow hierarchical composition. So using subtrees inside other trees and so on. Something that I strongly rejected. Something that is very popular in model-driven development is code generation. So you start from the model, and then people try to generate C++ code that need to be compiled. Don't do that. Don't do that. Don't need to. Who does that don't understand a lot of design patterns that already exist that you can use and that we use. So for example, what we do instead is making a good use of the factory pattern instead of code generation, and with absolutely zero penalty. For those of you that are already familiar, it's not a surprise for anybody else. Really, the way you express behavior trees in this library is with the implementation of the specific node in C++. That's why it's called .C++. And but then the composition of the tree is in a scripting language, and of course XML was like a natural candidate for that, because XML are represented with a tree, really. So and there are a lot of tools supported. So I could have created my own script language, but there was no reason to do that. But the point is that we have a compiled part that is the single node, but the tree is always a scripting language. This is very powerful for many reasons. First of all, there is a strong separation between the model, is the tree, and the actual implementation. So, and this separation is so strong that they're not even the same language. And here I'd like to mention my experience in a company that was using the PyTrees. PyTrees is a great library, and I don't have anything against that. But the fact that everything was expressed in Python did not block people from mixing together in a way that maybe you can prevent with a little bit of discipline. They were mixing together definition of the tree, the business logic, implementation, everything was mixed together. So once again, the only way you could understand the tree was to really inspect the code yourself line by line without any idea where the tree definition would be, and maybe it was in multiple files. So instead, in this library, you have a specific location, the XML, where the tree is visible. You don't need to open several files or look in a 1,000 line Python file to find a certain piece of information. And also something that is very powerful is the fact that thanks to this let's say textual representation of the tree, you can use editors. So without, as I said before, without any code generation, you can is also naturally serialized, because the same XML used to create the tree at runtime is it can be sent over the wire, and then you can tell to an external tool that is doing monitoring about how the tree is, what is the shape of the tree, which are the nodes of the tree. So you have serialization for free. You have tooling. You don't need to recompile anything if you change something in your tree, if you rearrange or change some parameters. So this is really, really powerful. And as I said before, this comes with zero overhead. So you have the initialization phase where you create the object, but then at the runtime, there's absolutely zero penalty. You could have created that with a hard-coded C++ or code generation. It would not be faster. So there is the same data structure that you would have with code generation. So another topic, so changing now topic, this is one of those things that I mentioned that about the model. So looking at this as model-driven development. So one of the things I realized when I started working on this library is that many implementation implement the blackboard in a way that I think is not correct. As a reminder, the blackboard is a map of key value, is a key value storage, basically, that is used to share information from one node to another. In this case, we have a sequence when, let's suppose, a manipulator. First of all, we have some camera that detect an object to be grasped, and then we detect the position of this object with the camera, and we need somehow to communicate this output to another node that is grasp object that is not aware that there is a camera, just need to know where is the object to be grasped. So we need to have this kind of data flow between these two nodes. The problem is that in many implementation, this is done under the hood. So, and once again, if in PyTree I had to look at this data flow, the only way to do that would be with some grep or find really inspecting the code line by line to try to find who is writing and who is reading from the Blackboard. So one of the, I think, innovation, or I don't know how to call it, things that we do differently is that we decided that this is really important for people to understand what's going on. So the Blackboard is now part of the model. So there's the software implementation, but this is something that is not opaque anymore. This is part of the model. This is exposed to the user. And also, as a better representation of this data flow, we use input and output ports. That is, under the hood, the implementation is the same. There's a Blackboard. But what the person, the behavior designer see is really an input port and an output port, and they're connected because they're pointing to the same value. And this is not unlike, a topic in ROS. There's one publisher and one subscriber. So at the end of the day, we want to know how a certain element talk to another, and actually they are talking to each other. So this is something that we do differently. This also allows us during the deployment time to do some extra checks. For example, we do type check and we say, oh, you're trying to connect a string to a role PTO. I don't know what you're trying to do. So sometimes there's unless you provide that compilation time a function that converts a string to object, then this will not even start. So there is some extra type checks that are done at not really a compilation time, but a deployment time. So you can find errors pretty early. Or sometimes you say, oh, you have this input port, but there is no output. So this input port will always be without any input because I don't see where the other is. So there's some kind of static analysis you can do thanks to the fact that we expose this at the level of the model. Another topic, so changing now topic, I also want to talk about something that I think was mentioned in the last meeting very briefly or not, or maybe offline. So I don't know if this is the first time it's done in this way, but something we do that I haven't seen in the literature is the scoped Blackboard. So of course we can compose this pretty natural. We can compose multiple behavior trees, including one inside another. Here there is an example. Even if the tree itself is what I say it's intrinsically hierarchical. What I mean is that you can always take a random node in this tree, cut everything that is below it, and that is a subtree, right? So you can always have this kind of encapsulation, but at the implementation level, we can have multiple files implementing a certain subtree, and then we include one inside another, and so this is really important in terms of design. And if you think about it, this is not different from what we do in programming languages, right? To reduce the complexity or to avoid copy and pasting and repeating over and over the same piece of code, what we do is create a routine or functions, and then they call other functions, and then I can have this invoked in multiple places. So, right, this is not different. But as soon as I start thinking about it as a domain-specific programming language, then the same best practices I'm using in my Java, Python, or C++ becomes valid also in the context of BT. Now, if I go back to the idea of the Blackboard as a global key value storage, this is telling me that this is a bunch of global variables, and we know how bad that is it's okay for very small programs. But as soon as you include one library inside another, or your program has become larger, everybody knows how bad it is to have global variables. And the same the same is true here in behavior trees. So having a single blackboard is convenient. Of course, it is less reasoning you need to do, but very soon you will have the name target, and that name target means 2D position in one node and something else in another node, and you have a name collision. And then the program cannot make sense of this anymore. And we know already in programming what the solution is. We can use namespaces. Of course, this is just about making the name longer. But the best mechanism we have is the scope. We can define local variables that are visible only in a tiny scope. So using this intuition, what we implemented is the scoped blackboard. So a blackboard is visible only inside a specific subtree, and not from the point of view of the parent or the siblings. So if we want to have that visibility, what we do is an explicit port remapping. And thanks to the fact that we do remapping, we can also change the name. So you can see that here at the main tree, we have these magenta, pink names, and we remap them to the blue one by one. Of course, there is also a shortcut in BehaviorTree.CPP where you can check Boolean and say, if they have the same name, just remap them. So
Davide?
it is about, yes?
Davide, could I please ask you to close the presentation within the next couple of minutes so that we also have some time?
Sure. I
discussion?
promised it was fast, but I lied to you. So okay, so
course.
just I'm jumping then to what I mentioned, the observer. So the fact that we have this mechanism to we basically notify multiple loggers and observers when there's a state transition. This is very powerful because it allows us to in a non-intrusive way to create file logging, real-time monitoring, unit test, and without changing our code. So this is non-intrusive and allow us to create all these tools. And then this is I'm suggesting people to look at the presentation at ROSCON 2. There's this new mechanism that I introduced it in version 4 with a pre and post condition. It's basically add a very simple scripting language on top of behavior trees to reduce the complexity. So here on the left, you can see something that for me is very complex. There's a complex network of control nodes and decorator to do something that in my head is very easy. And I can express now this in a much more straightforward way with this post condition here. And there are very few, but very powerful. Here you can see an example of saying, please go into emergency landing for this drone if your voltage is below a certain level, and then change your global state to land it. So you can see how now there's much more expressiveness in the way you express trees. So yeah, I'm inside the 2 minutes.
Perfect. Yeah.
Thanks.
Thank you very much.
Thank you.
Yeah, so then thank you very much for this presentation. I think it's very important to have you in this working group. So, but I really would like to kind of also get some, maybe talk to you a little bit on this. So, are there any questions from the audience? Do you have any questions, anything you would like to ask Davide? Yes, Alex?
So with my tree in XML and my code in C++, and please forgive my ignorance because I'm completely new to BT.CPP, can I modify my behavior tree online?
Yeah. So what you can do? What you can do on okay, online? You mean during the execution without
Yes.
stopping the tree? No, you can't. That was something I wanted to do for a long time, but the problem is that some nodes are stateful. So imagine a node like a retry until successful with a top limit of 5. If you remove that at some point, this is a stateful node. There are many stateful nodes in the tree. So as soon as you change the tree, you can abort completely the previous state and create a new one. That is possible, but it's not really like live updating. It's like more like live killing everything and restart. So you can do that without recompiling, but you completely lose the state in which you was before.
So what you're saying is this is a complex problem that is very specific to how you design to tree and the situation your system is in.
Exactly. Let's say that there is no way to do hot reloading without destroying completely the state in which you are. If you can sacrifice that, then yes, you can. But it's more complex than that. That's why I don't provide this out of the box.
Okay. Can I snapshot the state and reason about it and implement whatever state I like in the new one I create?
Go ahead. Go ahead if you can. I personally find this extremely challenging once you go into the details. But if you find a nice way to do that, get in touch with me.
Thank you.
Okay, are there any other questions? Yes, Gianni?
Thank you for the presentation. Yeah, sorry. I was wondering, the actual execution of the action, do you defer that to other nodes normally?
That is in the context of ROS, that is considered best practice. So usually you can do both. So I don't have any preference personally about that. But in the context of ROS, it's much easier to do that using either service or ROS actions, and say, okay, my node will just be a action client, and the actual node implementing where this is the implementation is this one on another process. So that is best practice, but there's no reason why you can't do one thing or the other. I have users that don't use ROS, so the implementation is in the actual node and not delegated to an external one.
Okay. Thank you.
Maybe on top of that question, I have the question that have you ever thought about like standardizing these interfaces? Because when you talked about that you want the whole system behavior be understandable in this behavior tree, right? Then you can only really do this if you have a clear understanding of what this action is doing. Otherwise, still have to look into the implementation of this action.
Mm-hmm. That's correct. So I'm after when you look at ROS, I think the ROS demonstrated the best way to standardize something is popularity. So you can try to standardize by committee. That I haven't seen that succeeding very often. But then ROS comes and say, this is the way a laser message is. This is the way a point class message is. We know that works because we have tried that over and over again. And anybody in the community agrees that it's good enough. And that's it. The more people use something, the more standardized it is. So I'm really looking forward to have discussion with others and maybe having this kind of guidelines written. But at the end of the day, I believe in this being something bottom up rather than top down. Let's say that I've seen bottom up projects being much more successful. And so let's say I'm not against it. And I'm very open to start having this discussion with others.
Okay. Yes, Jake.
Yeah, so this is, I guess, slightly off topic from the contents in the a presentation, but it is a behavior tree and group question.
Okay.
Is I've been very interested in some of the features that you listed coming up on group 2, things like starting and stopping the tree, breakpoints, things like that. Do you have any roadmap on when those things will be coming down the pipeline?
Yeah, actually, it is already done. So that's already working perfectly. And probably, as some of you know, Group 2, that is a completely optional tool, doesn't prevent you in any way from using the library, is now released as commercial software. So there is something that is free, in particular for academia, is 100% free, all the features. And then for industry, there are some free features like the editor and other paid one. And what you mentioned is basically the ability to create breakpoints or mocking at runtime. So at runtime, you can mock a certain component like a camera and say, okay, don't execute the code, just return success every time. Or maybe doing a fault injection. So say, oh, the next time you execute that, automatically fail. Even if you would like to succeed, just fail because I want to check my recovery behavior, for example. So that is already implemented. There are some companies that are testing it right now, and the official release to a broader audience will be very soon. But it is already implemented.
Cool, thanks.
So maybe also in terms of understanding the system behavior by looking at the tree, what is your take on especially when you look at the navigation 2 implementation, you find tons of custom codes, custom nodes. I think in the standard navigation 2 behavior tree, there's almost no kind of standard sequence node or whatever. These are all customly implemented control nodes. I mean, of course, this is possible with your library, but wouldn't you agree that it maybe makes sense to use more standard nodes to also ease this understandability?
So actually, no. I think that is something that I think is good. So I always say that you need to look at this as an extensible domain-specific language. So is there a specific pattern that you see repeating over and over again? And I'll give you a very simple example. I introduced something that I've never seen in other implementation, that is if then else, right? Something so basic like that would require, with the nodes I see in the literature, 3 nodes just to express something that basic, something that for me in my head is a primitive, right? So I cannot enter into the head of everybody. So I will always say, is there a particular pattern that is repeated over and over? Just create your own. I think that is good. What I can't do is include all of them in my library. But sometimes when I see a pattern that I agree is very useful and repeated by many people, then I do. For example, in the last version, I added the run once decorator that say, okay, this code will never be executed more than once. So because a lot of people do something like that for initialization, so they kind of reinvent the wheel. So I try not to take everything that people want me to do. I think it's good that they have their own implementation, but if I see a pattern that is particularly useful or broadly used, then I will extend my library to include that.
Okay, I understand. Yeah, I guess these are different, philosophies on that. I mean, you also mentioned this in your Roscon talk, that you can always kind of push for purity in the structure. You can go for utility of whoever does this, whoever uses the software. So I hope there's no other urgent question. Otherwise, we could also, of course, continue this in the next meeting in a month. I hope you are available, Davide.
Sure.
But otherwise, please, Sebastian, continue with your presentation. Again, thank you very much for agreeing to. I think it also kind of came out of the last meeting.
Yes.
Yeah.
Okay, great. Thank you. I'm just gonna share my entire screen to make that a little bit easier. Hopefully you can all see that.
Yes.
I don't see it on my end. Cool. So yeah, thanks Davide for teeing up that great behavior tree presentation. I guess this week is the picnic domination of the ROS Deliberation Working Group. Yeah, so my talk today is going to be on integrated task and motion planning with ROS2 and PDDLStream. My name is Sebastian Castro. I'm a senior robotics engineer here at Picnic. Although most of this work I'm doing is based out of a previous job / turned personal project, so I'll be discussing that as well. Davide is someone who needs no introduction in the ROS community, but I think I might still, so I'm going to do a quick introduction to myself and then move on to the actual content. So just a little bit about my background in the deliberation context, right? I started doing my academic research with a topic on high-level control of modular robots. So this had to do really with synthesizing task specifications from human language into something kind of encoded with linear and temporal logic for verifiable behavior. That then kind of took me to the path of really working, I don't know, on kind of across the entire robotics stack for robotics education. I actually spent a lot of my career at MathWorks being a kind of a technical lead for robotics student competitions, in particular the RoboCup competition. So that's where I really got into kind of the MATLAB ROS ecosystem and using tools like state machines, using their Stateflow product to encode you know, high-level behavior of a robot. And that's kind of one of my favorite things to show. Beyond that, I then kind of moved on to becoming a full software engineer, where I worked for a research group at the MIT Computer Science and AI Lab in Professor Nick Roy's group, where I was basically in charge of standing up a kind of an entire stack for a home service robot for different research demonstrations. Continuing the behavior trend, I worked at Boston Dynamics on the stretch truck unloading robot, on basically more of a, we are talking about in this presentation, so lots of, you know, recovery behaviors, behavior switching, to make sure that the robot never actually stops operating, and if it does, you have a very clear indicator of why it stopped working. And, you know, kind of get kicked back into the open source behavior tree world in my current role at Picnic, where I'm working on the Move It Studio tool, which is, among many things, it provides a bunch of developer tools for, you know, creating autonomous behaviors, using actually BehaviorTree.CPP, but also leveraging the power of Move It for motion planning, and just ROS in general for other types of behaviors. So I'm actually going to focus in on the MIT CSAIL project, because this is kind of where my task and motion planning background kind of spun up. This is kind of the high-level diagram of the whole thing, and I'm not going to go through it in too much detail, but the idea is that you have some natural language thing that gets synthesized to a specification that gets put through a task and motion planner. The plan that results from this planner is actually executed as behavior trees. So, you know, very relevant to this group, hopefully. Kind of the three highlights of this project really were that the platform that we're using, the Toyota Human Support Robot, is a ROS-enabled robot. So lots of the stuff we want to talk about here. It was my first exposure to behavior trees. Sorry, Davide, but it was in PyTrees because it was a fully Python stack. So I have a lot of similar things, like the questions that have been asked by the audience about, yeah, PyTrees lets you do a lot of runtime modifications and you know, doesn't use strong typing. And I shot myself in the foot quite a few times in developing this stack. So take the power with great warning. And most importantly to this talk, it was my first exposure to task and motion planning. Actually, as part of this group, we shared a lab space with Professors Leslie Kaelbling and Tomás Lozano Perez, who are basically big task and motion planning people, for those in the audience. So one of their students had recently developed this tool called PDDLStream, which was used as part of our stack. So I'll be kind of digging into that, as well as my open source kind of simulator wrapper around that. You know, once I consider myself fairly proud of this work. So once I kind of moved on to other opportunities, I actually took a lot of the task and motion planning and simulation backend that I used to validate my planners into an open source package that's available now. So you can actually find that online under the name PyRoboSim, and it really is basically a kind of a 2.5D little point robot simulator that you can use to kind of hook into task and motion planners and use it either as a standalone Python tool or through ROS2. So I'll just do a really quick demo of this. This goes on. Hopefully you can see my VS Code window and not still the slides. So I'm going to open up the PyRoboSim tool, and that's just going to kick off a task and motion plan in the background. And then I'm also just going to quickly open up an RQT graph here. Essentially, it's saying that you've got a bunch of ROS nodes. You've got a node that's publishing some kind of goal specification to a planner. The planner then receives that goal specification and converts it to an actual planner sequence of actions, and that goes into our kind of core simulator world. This thing is planning for a while because I threw kind of the biggest TAMP problem at it. What I'm trying to do here is that you basically got a robot here that's navigating an environment with a bunch of different rooms. Each room has different locations where objects can exist, and the objects themselves are also entities in the world. And then in kind of Python code or ROS, whatever you want to call it, we have the ability to specify different sets of goal predicates for what we want our desired state of the world to be. So this thing is, again, it takes anywhere between 30 seconds and a few minutes to plan for this particular complicated problem, because in the spirit of continuous of integrated task and motion planning, we're actually sampling not just the high-level tasks for a robot to do, but actually the kind of how the robot should accomplish those tasks, right? So you've got things like sampling, motion plans for the mobile base to navigate, sampling placement positions for objects in cluttered environments, and so on. So we'll kind of let that go for a little bit and see how that turns out. If not, then I can always simplify the domain and replan. Let's see if this wants to go. It's also bogged down a little bit by the fact that I'm presenting, but that shouldn't be a huge scaling factor. Well, as I scroll through the output here, basically what's happening is there's a lot of different things being sampled as far as navigation and manipulation actions. Maybe eventually we'll get a plan. If not, I will maybe take this down to a simpler planning domain so that I don't have you around. Okay, let's do that. Okay. So this is a simpler domain that doesn't sample any manipulation actions, rather just samples navigation actions. So it's a lot quicker. What you see here is that you have basically, well, the ROS logging is kind of annoying, but in its length. But basically the output of the solution to my task and motion plan is a list of 17 steps, including things like navigating between rooms, picking objects, placing objects, etc. And now the robot is, going on and doing, I guess it's 16 different actions in order to rearrange the world and all the objects in it. So the idea behind a tool like this is I actually ended up using a simpler version of this for my work on a real robot, where it was much easier to iterate here than it was in Gazebo, where the robot takes a long time to execute, has a lot of setup, and of course on the real robot. So it's one of those things where simulation works to your advantage. If the simulator, if it doesn't work in simulation, it won't work in the real world. But if it doesn't work in simulation, it absolutely will not work in the real world. Okay. So it's just a quick kind of fumble through a hands-on demo a little bit. So I wanted to kind of bring it back a little bit as to, maybe give a little introduction on task planning versus integrated task and motion planning, and my thoughts on the ROSification of this whole thing. So as a quick recap, task planning typically deals with purely symbolic actions. So you have a robot that's trying to move or execute some action. In this case, I'm using the example of moving from one room to the other. When you're doing this kind of planning, you can use something like PDDL to specify an action, again, where you've got a bunch of parameters. In particular, things like the locations they typically are discrete parameters that come from a finite set. So you're actually just enumerating your parameters to search over and coming up with a solution of a high level plan. The key here is that the feasibility of that motion plan has two options, right? You either delegate this to execution time, so you say, okay, I know that I'm going to move from room 1 to room 2. I assume I have a motion planner that can give me a valid plan. Or maybe I assume I have a planner that kind of works, but if I encounter obstacles, I can, recover while I'm actually running the behavior online. And then the other option is to capture some of these feasibility notions through actual domain knowledge. So for example, if you're trying to move between rooms that aren't actually connected, so you could never find a motion plan, in your domain specification, you could add something like this connected predicate that says, well, you can only move from one room to the other if these are tagged explicitly as connected. But that involves manual design of your domain. So the key behind integrated task and motion planning is you basically, in addition to these symbolic discrete parameters, you encode in actual metric information about things involving motion planning. So what the start and goal poses are, what the path or trajectory is, anything else that you can really, kind of ground to real things in the physical world, like poses or paths and so on. Of course, this comes at a cost in the sense that you have to do a lot more motion planning up front. So one such tool to do that is this PDDLStream, which I'm talking about today, which is one tool that basically balances this search over symbolic parameters with actually sampling some of these continuous valued parameters for motion primitives. The idea is that you have to enrich your PDDL domain with a couple of other things. I've highlighted a few things here in red and blue. Like in the same move action, now you have to basically sample a navigation target pose, let's say, if you want to go to a particular location. And you might also need to sample an actual motion. So this is maybe like a path generated from an RRT or something similar. PDDLStream actually extends the language itself by additionally including this notion of a stream file. The idea is that you basically have something that tells you, hey, this nav pose that I want to sample, during search, I'm going to deal with it as if it were a hypothetical thing, and only when I get to the sampling pose, I have my own sampling functions that I can register, in this case as Python functions, that will actually generate feasible instances of those parameters. This is a very high-level introduction. I would encourage you to read more in the publications, but the idea is that essentially it's PDDL with some way of injecting continuous valued parameters that you can sample at key points during search. So the way that a typical problem like this would work is that, if you have some domain like this where your goal is to put the apple on a table, it's not sufficient to just reason about the symbolic action, because a solution to this problem might be just pick up the apple and put it somewhere on the table. But in this case, hey, the table is cluttered, and in fact, there is free space on the table, but you can't reach it because there are walls in the map. So you actually have to reason about the feasibility of motion plans to get a complex sequence where you actually end up, picking up another object to free up the table and rearranging the whole world so that it actually takes 8 high-level actions to get to your desired goal state, as a quick example. So in ROS world, I'm going to try to get through this pretty quickly. It's a pretty general architecture. I don't think it's anything too novel here, but the idea is that you have some user node that is sending a goal specification to a planner. The planner either succeeds or fails, and that plan needs to get passed to something that executes that list of actions. And then you also need that executor to send commands to your robot, real or simulated. Nothing huge there. The key here is that, again, the task and motion planner, if you're using PDDLStream, it requires both a domain and these sampling functions. And of course, in the plan executor, you need a library of skills and behaviors that you can pull from that basically ground those high-level actions with their continuous parameters to something you can run. And tools like BehaviorTree.CPP are very much adept at handling this kind of solving this kind of problem. So as far as what you would need to really capture task and motion planning in ROS, it's a couple of things, right? As far as the inputs to the planner, you first need to specify a goal specification. And in this case, you might think of your goal specification being a list of predicates that could have some kind of type, like where you're talking about like the an apple is on the table, there could be a predicate that encodes that on relationship, and then a couple of arguments. And then you also, more importantly, need an initial state of the world. And don't worry about all this dump here. The key problem in something like this is that particularly the initial state for one of these planning problems is very much domain specific. You're going to have a lot of different parameters here. The way that tools like PlanSys2 end up addressing this is basically by telling you as the author to create your own initial state and specification in a text file. So in that sense, that there is also like that problem just persists in every tool that uses PDDL. Most people spend a lot of time getting their problem in a state where you can pass in an input to a PDDL solver. So there's a balance here between how generic and how easy you want people to do their own customization. But the idea is that the long and short is that you need both your initial state and your desired goal state to be part of the query to the planner. The planner then has to output things, and this is where it becomes fun, because in tools like PlanSys2, the way that the actions work is that you have a task plan which contains a list of actions, and then there is, just like shown here at the beginning, there is a list of string arguments that define kind of the extra symbolic arguments. For task and motion planning, you don't have that luxury. Basically, you also need additional data that captures all this metric information. And this is just an example of many things you could add, but things like poses for navigation targets or manipulation targets, entire motion plans like path or trajectories, both in Cartesian and configuration space. And you might even have other representations like twists here that could capture more complicated motions, things like arc motions or twisting motions. So I think ROS has a lot of this standard message. They have a lot of standard messages for this kind of stuff. And there's again a balance here between how much we want to throw into a standard implementation of a task plan versus letting the user define what they need. So I guess my takeaway is it's very challenging to come up with something standard for integrated task and motion planning. But I gathered some thoughts, and I'm going to stop after this slide. The three big opportunities I see for something like this to really become a collaborative effort is, one, I think PlanSys2 has a lot of great tooling, and of course extensions that allow it to also perform integrated task and motion planning are going to be key. And this includes actually adding solver support for solvers that do support this. This is kind of how this presentation came to be. But then also we're talking about this notion of like your domain specificity in your initial conditions and your goal specification. Could this ever be like a standard ROS message, or do people have to deal with it on their own? I also think that behavior trees become, or things that can execute behaviors like behavior trees become key here, because these high-level tasks with a lot of motion queries and stuff require complicated solutions. So like when you consider your planner outputting a single action, there could actually be a lot of different motion planning, execution, reactivity going on under the hood. So having complicated subtrees that tell people, like, hey, the plan thinks this is simple, but there's actually a lot of robotics logic going on under the hood, would be very useful here. And then the last one, which is I think the biggest thought that I had, is stop reinventing the behavior tree executor. I think every single person has their own implementation. Like if you are using behavior trees, you have your own thing that like starts a behavior tree and cancels it and then switches to another one. We're doing it on Move It Studio. PlanSys2 decided to try ROS actions, and we're like, yeah, this doesn't do it for me. I'm going to do my own lifecycle node solution. I'm guessing there's probably many of you guys have your own thing. So is this also an opportunity for us to kind of move faster, in the sense that you basically we kind of complete the pipeline that bridges this high level task planning with actually executing in ROS without putting a lot of manual work on our entire developer community. So yeah, that's my rapid fire intro to all this. Thank you for listening. I've got a couple links here. The slides should be shared, and I know we're over time, but wanted to open up for questions.
Yeah, thank you very much for your talk, Sebastian. Are there any questions? Yes. And sorry for the bad moderation, otherwise this would be over on time. But I see, like, almost all participants are still here, so I take this as you have time. Me too. Barely. Okay, so if there are no other questions, I think again, if I take your last slide in terms of standardization, I think again it would make sense if you, for example, say you don't want to reinvent the behavior tree execution and say you need to use an implementation like BT.CPP. I feel like it would make sense to think about how kind of the actions could be more coupled more closely to the tree. Because otherwise, yeah, I mean, you could of course put out an XML to execute the standardized behavior tree, but it would be still not clear what the actions are and the conditions, of course. Would you agree?
Yeah, I think Plansys 2 tries to address this in some way. I know that they have their own kind of custom behavior tree generator as well, but the idea is that you have a way to register, like in your PDDL domain, if you have, X number of possible actions, then you have X lifecycle nodes that do a unique thing. And then those define kind of the starting and stopping of that action. And then I think there's like a thin wrapper on top of that that tells you, when something succeeded, when something failed.
Okay.
I guess what I'm thinking about it is more like if you have a planner that's, constantly replanning and giving you new things to update, how do you cleanly cancel out of your existing plan and start a new one? I think a lot of people are making that on their own right now. Not so much the registration part, which I think there's a lot of good tooling for that.
Yeah, but often it's unclear how kind of what is a success, what is running between the behavior tree action and the ROS action, even though they share the same name.
Exactly. I think like if you had a ROS action, then you have the result message, which should pipe in the result of your roots of your behavior tree. I think the lifecycle node similarly has its own state machine where you have to manually map the terminal state of the tree to the lifecycle state.
Yeah.
So yeah, lots of room for manual error there or other timing fun.
Okay. So yeah, if there are no other questions, this means that your presentation was very good, self-explanatory. So thanks again. And I think it would make sense to continue this discussion on potential, better linking of these things with each other. I
Thank you.
again want to share the call for other presentations. So if you wanna present something, feel free to approach me. Otherwise, I also will probably contact some people before the next meeting. And again, sorry for for taking 11 minutes of your evening. Have a good summer, everybody. And see you in a month.
Bye.
From a TGV. Bye.
Have a nice evening.
Thank you.